Okay, this is going to be a video here on integration of inverse trigonometric functions. These were the lecture we gave, the formulas that we gave last time, inverse trig functions, and I even have a formula sheet that I'll be referring to. Right in here. I guess these are the inverse trig functions. All right, so let's try some of these out here. And I think we want to add some pages. Okay, add a page. Add a page. We want to add some pages here. Okay. Okay, so let's try the first one here. Okay, so here we go. Now notice this, that we have a constant here. We're going to pull out the constant. So this is 4 times the integral of square root 1 minus x squared dx. So we want to recognize the formula here for this particular integral. Okay, so we want to know what we're going to use here. Now, let's go to the formula sheet. And whenever you see that particular integral, you're going to use the inverse sine x plus c here. So we get to replace this with inverse sine x plus c. And now we could distribute 4 inverse sine x plus 4c here. And this whole thing is a constant. And there you go. Okay, so this is how we handle question number 1. And we're going to take a look now. We're going to go to question number 3. And for question 3, we notice again we have another constant. We're going to pull out that constant. So this is going to become 6 times the integral of 1 over x squared plus 1 dx. So now we have to look for the formula for the integral of 1 over 1 plus x, 1 over x squared plus 1. So going back to this formula, it's right here. If we ever see this integral, it's inverse tangent x plus c. Okay, so we get to replace that with inverse tangent x plus c. And of course, this becomes a constant, so we have 6 inverse tangent x plus c. And there you go. This is how we handle number 3. Okay. Number 5. So notice for number 5 again, you have a constant here, and you can pull out your constant. 3 integral 1 over x squared plus 4 dx. So here we have to identify what formula we could use here for number 5. 1 over x squared plus 4. Remember, that's going to be thought of here as, 1 over x squared maybe plus 2 squared, where a, remember, a is 2 here. So go back to your formula sheet. And this is my point to you. This is that same integral, whether you have x squared plus a squared or a squared plus x squared. Here, we're going to need to know the value of a. It's going to go here. It's going to go here. This is the formula. So we're going to use 1 over a inverse tangent of x over a. And that's what you're going to use. 1 over a inverse tangent x over a. So in this case, a is 2 because 2 squared is 4. So this is the a value. So by that particular formula, this integral is really, you say 1 over a inverse tangent x over a plus c, but a is 2 now. So that's really going to be 1/2 inverse tangent x over 2 plus c because of the value of a. Goes here, 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 and here. But don't forget the constant of 3 gets multiplied to that whole thing. So we have 3 times 1/2 inverse tangent x over 2 plus c. So we want to distribute this. So we have 3/2 inverse tangent x over 2 plus 3c. Here's your constant. And there you go. This is the integral. And that's number 5. Let's take a look. Okay, number 7 now. Number 7 is going to be interesting. Number 7, notice again, we have a constant. We're going to start here with that constant. We get to pull it out. So you have 5 is the constant, 1 over 9x squared plus 1 dx. And so you look at this particular integral, and I think what's fair to notice is to observe is this 9x squared here. So this is going to be thought of as, this portion here is 3x in parentheses squared. So this particular integral now is 1 over 3x squared plus 1 dx. So I want you guys to observe that the 9x squared is really right in here. It's 3x in parentheses squared. Now, the reason you do this is because you're going to use U-substitution, where U here is that 3x. This is going to be your U. Okay, because you have a U-substitution formula here. This version down here, let's find it. Oh, I guess I didn't write it. But this is what you're going to be using now. But it's going to be with the variable u. So here's what I mean by that. I'm going to replace this with a u. This is a u. This is a u, so you have the u substitution version, u sub. Okay, so let's see how that works. Since u is going to be 3x, remember what we need. Du dx will be 3, and it's 3 over 1. But you get to cross multiply. So du times 1, 3 times dx, and du will be 3 dx. So divide both sides by 3. And you get du over 3 is dx. So dx, this is the u subversion. There's your dx. So when you convert now, 5, 1 over u squared plus 1. Now dx becomes, that's the du over 3 here that we're referring to. Right? This is du over 3. It's really dx. Now, you have a constant 3. You can pull that constant out. So you got 5/3, 1 over u squared plus 1 du. Now, this is what I mean. You're going to recognize that integral. The integral of 1 over u squared plus 1 du is the u substitution version here that we just converted here. And actually, I apologize. That's the wrong one. You might say, why is that the wrong one? I did think I had that. It's right here. I apologize. This is the one we're looking for. Okay. So it was there. I apologize. You did have the u substitution version there. Okay, let's get out an applause. Okay. Inverse tangent u plus c. So we get to replace this with inverse tangent of u plus c, where your u is 3x. Okay. 5/3 inverse tangent. You can say u plus c, and you distribute. Right? So you can say you get the 5/3 inverse tangent u. 5/3 c, this is going to be that c. So don't forget what u is. U is that 3x. So here's your final answer. So u is that 3x. It's right here. And there you go. And that one's number 7. Let's do number 9 now. Okay. Taking a look at this one now. There's a couple of things I want to point out to you. You got this 4x squared. We're going to write 4x squared as 2x in parentheses squared. That'll be 4x squared. And I'm going to say this 25, we're going to write as 5 squared. So my integral is 1 over 2x squared plus 5 squared dx. Okay. Now, again, just like the last question, this is going to be my u. So you're going to let this be your u. You're going to use u substitution. So u is 2x. Okay, so we have that u. And just to kind of observe what's going on, this will be 1 over u squared when we substitute. Now, you said, why did you write this 5 squared? Now, I'm going to change that color. I guess I'll use blue. Okay, this is going to be that a value now. Right? So we have an a value being 5. We're going to need to use that. And maybe I want to change the color, not from blue, maybe green. I don't know. We're going to see how that works here. And, of course, we need the dx portion. So the second you do u being 2x, what you want to do by u sub is you'll get the du dx is 2. Again, 2 over 1, you have a proportion, cross multiply, solve for your dx. And you'll get du is 2 dx, divide both sides now by 2. And you get du over 2 is dx. And we get to now replace that dx with the du over 2. So you get to pull out the constant of 2. So pulling out that constant now is 1/2 1 over u squared plus 5 squared du, where that a value is 5. We're going to see how this all works, because remember, what you want to now do is identify that formula here. Where do you find that? Okay. So go back to that formula list. Now remember, this is a u substitution for inverse tangent. And the one I was looking at, this is the one I'm looking at here. So if I had to write a u sub here for this, notice what this one is. This one is what we're looking for. This is x squared plus a squared, right? But now replace the x with the u. We're going to do the u subversion, and that will be du, which gives us 1 over a inverse tangent u over a. And that'll be plus c. So let's do a plus c down here, I guess. Okay, so I'm looking here, and this is what I'm getting. I'm going to copy this. Now remember what a is. A goes down here. A is 5. This is where a goes. So this is what we're going to use. This is a u subversion, for that formula. So altogether, here's what we'll have. Remember, this is going to be 1/2. And I get to now, since I know what a is 5. So I got to replace this with, I'll put it in red. This would be, 1/5 inverse tangent u over 5 plus c here. We get to replace that integral. So that's going to be 1/5 inverse tangent u over 5 plus that c. So when you multiply now, you distribute. This becomes 1/10 inverse tangent. Remember what u is, though. Go back, and what is u to begin with? Here's u. Should 2x. So we replace this 2x over 5. Yes, that can be 1/2 c, but you guys know by now that's just going to be your constant. And, we can just leave it as our answer like this. So there you go. So this is kind of how we use those integral formulas, ladies and gentlemen. It's U-substitution. So this is another good one to have on your formula sheet. Maybe you write that down for yourself. Okay. All right. Number 11. Now notice this one here. If I go back to the formula sheet, we might want to look for something we can use here, right? Let me go back. Here's my point. This here, if I look at the denominator, this is the square root of 1 minus 16x squared. So you may start to say, can I write this as 4x to the second power? And you can. In other words, 16x squared is really this 4x to the second power. Okay. Now, and then what's important to note is that this is the number 1. Okay. So you might say, why is that important? Because we're going to find this is going to look exactly like what we need here. This is the integral here of the square root of that 1. Be careful. There's a square root of 1 minus u squared. And that's inverse sine u plus c. So this is the formula that you use. It's a u subversion here of the formula on top. So that's what we're going to use, inverse sine u. So here's the point. My u value is 4x. Okay, so right in here, u is 4x. That's the u. So I'm going to say, okay, we let u be 4x, and then I need my du dx. That derivative is 4, and it's 4 over 1. Cross multiply, and you end up with du times 1 is 4 dx. Divide both sides by 4. We get du over 4 becomes that dx. So there's dx. It's right here. It's a du over 4. So when we do the substitution, that's 1 over square root 1 minus u squared. Now dx is du over 4. So don't forget to pull out the constant being 4. Okay, so now you recognize that integral, that formula we want to use. Right? It's right there. Inverse sine u. So we can just simply say this is going to be inverse sine of u, of course, plus c. And we want to know u here again. U is 4x. So here's the final answer. 1/4 inverse sine u being 4x. Yes, plus c. You're going to distribute. But by now, maybe you say, Mr. Judge, I don't have to write down that 1/4 c. I know it's a constant eventually. I'm going straight to write that down. You certainly can do that. And there you go. All right. It's number 11. $13. Okay, so this is kind of an interesting question here. Kind of looks like that inverse tangent. It's going to be that. Here's what I mean. You see, this is going to be here. We're going to write this e to the 4x. We can write as e to the 2x squared. Notice you still have that 1 there. So what we're going to say now is we're going to let u be this e to the 2x. So du dx, we differentiate e to the 2x, which is e to the 2x times that derivative of what? 2x. And that's a 2. Du dx becomes e to the 2x times 2. Now, this is a proportion. And remember, we need to solve for dx. So this will be du equals 2 e to the 2x times dx. Now, divide both sides by 2, e to the 2x. And du 2 e to the 2x dx. Du over 2 e to the 2x. Okay. So let's see what we get by u sub. We have the e to the 2x. That's still on top. That's now 1 plus u squared now, because this is u, remember? And dx is du over 2e to the 2x. That was the orange one, right? Yeah. All right, so now your cancellation. If you notice here, what goes away is that e to the 2x. The constant of 2 is still here, so we get to pull that 2 out. So 1/2, 1 over 1 plus u squared du. I'm going to copy all of that, or at least move it down maybe. Okay. There we go. So at this point, here's what we get. That's inverse tangent u plus c. So we identify the formula. 1/2 inverse tangent u plus c. We get to distribute that. So it'll be 1/2. Remember what u is. Inverse tangent u here is going to be e to the 2x. We have it right here. So replace that with e to the 2x plus, yes, it'll be 1/2 c, but by now you've seen enough to know that that's just going to end up being a constant, so you could just put a constant there. You leave it like it is. And there you go, ladies and gentlemen. It's your formula. It's number 13. So 13 looked a little strange. Okay, let's look at number 15. All right, this one is going to be the same kind of thing, but we got to look at that square root of 1. Square root of 1. Look at your formulas. Ah, we're looking right at it. Okay. Inverse sine. So here's what I'm saying here. Notice what we have here. That's e to the x squared. So, okay, there's my e to the x there. So this is going to be my u. So we let u be e to the x. So your du dx is simply the derivative of e to the x, which is e to the x. So du dx is that ratio e to the x over 1. So you get to do your cross multiplication to solve for dx. Du times 1 is du, and then you get ex dx. Divide both sides by e to the x. And you get du over e to the x is dx. So there's that dx. Okay, so when we do our substitution, we have e to the x here over square root 1 minus that u squared, because e to the 2x is e to the x squared, right? So, okay, now we know what is dx. It's going to be du over e to the x. So, du over e to the x. So I get to cancel. Okay. And you end up with the integral 1 over square root 1 minus u squared du. So the question is, what integral is this? And like we said, it's right in front of you here. It's the u sub version of inverse sine u. That's what it is. Okay, inverse sine. So let's move this all down, I guess. So we can say you are inverse sine u plus c, but you know what u is? E to the x. And there you go. Number 15. And then 17 is also interesting. Copy 17. And that looks like something that we already did. We see this square root down here of, 1 minus x to the 6. You say, well, that's not x squared. But let's see what we can do if I can make it x squared. If this is x squared, here's what I mean. Something squared. And say, what does that have to be? X cubed. So this is going to be my u now. So I'll let my u be x cubed, because 3, x to the third power raised to the second power, you take the 3 times 2, that's x to the 6. So that's what we have here. So this is going to be my u. And now du dx is d dx of x cubed, which will be 3x squared. Remember, that's going to be over 1. What I'm saying is, you write du dx as 3x squared over 1. It's really 3x squared, because you're going to create a proportion so you can cross multiply and solve for what you need. You say this would be du 3x squared dx. So you divide both sides by 3x squared. Cancellation. Du over 3x squared is your dx. This is what we're looking for. Du over 3x squared for dx. Okay. We already have the x squared there. This is the square root. 1 minus u squared. Now, this is the dx we're talking about. Du over that 3x squared we just found. That was in orange. Okay. There it is. Don't forget to bring the 3 here. Bring that down. And here you are again. You're saying, what do I do with this? This, ladies and gentlemen, again is inverse sine u plus c. This is the square root of, this is what we're looking for. All right. Again, it's the u sub version of the formula on top. So this is why you always need a formula and the u sub version, because the u sub is going to be probably what you end up working with. So final answer, don't forget what u was. And u is x to the third power here. All right. And there you go. All right, that was number 17, so we're going to do 19 now. '19 is very similar. Doesn't seem like you can integrate it this way. Here's what I mean. This portion here, we want to write with the power 2 outside. And that means I have to have x squared, because x squared squared, you just multiply the powers, you get x to the 4th. That's going to be your u. Right, so u will be x squared. And again, by u substitution, du dx is d dx of x squared, which is 2x. So du dx is 2x, that's 2x over 1. So 1 times du is simply du, then 2x dx, divide both sides by the 2x here. And you'll get du over 2x is dx. There we go. So this is what we need for dx. It's du over 2x. Now that's going to go here, but don't forget, we already have the x on top. This is now 1 plus u squared, where dx again is du over the 2x, as we can see here. So we have cancellation, and now that's going to be a constant of a 2. So we get 1/2 integral 1 over 1 plus u squared du. And then, was there a square root there? No, there wasn't. So if you guys remember this one, this is going to be the inverse tangent. Go back to this formula. It's not there. It's right here. There it is. This is what we're looking at. Okay, it's a u subversion for the inverse tangent function. All right. Inverse tangent of u plus c. What is u going to be? Remember, u is going to be what here? U is x squared. And there you go. U is x squared here. Okay, so number 19. So it looks like we weren't going to be able to do that one, but we are. These are all the inverse trig function integral questions. So 21 is an interesting one too. 21 is like one of my all-time favorite question. Well, I should say I have a lot of all-time favorites, or I should say I have a lot of favorites, not all-time. This is one you'll see over and over again, and I recommend you guys study this and take a look at this one here. Okay. Notice you have a numerator here that's composed of a sum now. Okay, it's a sum of two functions. So what I'm going to say is you can write this as x over x squared plus 4 plus 4 over x squared plus 4, and that'll be dx. Okay, so we're going to use properties of integrals here. This is integral of, look at the sum of two functions where they have the same denominator. You know, x squared plus 4, the same denominator. Now, the integral of a sum is sum of integrals x squared plus 4 dx, plus now this is a 4 over x squared plus 4 dx. So there's two integrals here. Now recognize this, the second integral, a constant comes out. So I have x here, x squared plus 4 dx, plus 4, 1 over x squared plus 4 dx. Okay, so there's two integrals. Let me share with you guys this one. Integral 1, integral 2. Just change the color. I1, I2. There's a constant 4. So I have a sum of two integrals. Now I'm going to recommend you guys do these integrals separate. So I don't know, integral 1. I don't know if you could even see that one. Let's keep it with blue. So I'm going to do the first one. Integral 1. I'll put I1 here. We'll shade that one. X over x squared plus 4 dx. Now the denominator, here's what we're going to say. We're going to let this whole thing be u. Okay, so this is u. And you say, well, why is that not, inverse tangent? Because what you see up here is not 1. That's x. So you're going to see what happens with that. So, okay, let's continue. If we let u be x squared plus 1, du dx becomes d dx of x squared plus 1, which is going to be simply 2x. So du dx is 2x over 1. You're going to cross multiply, diagonal across. So you get du times 1, which is just du, and then 2x dx. Remember, you're solving for dx, so divide both sides by that 2x. And you end up with du over 2x becomes dx. That's the orange there. This is the orange. This is for that first integral. So, the integral of x, now this is the u, because this is what you said that u be. We just found out that dx is du over 2x. This is that orange thing we just found out. And don't forget, there was already that x to begin with. So when you start to do the arithmetic, yes, your x cancels. You got the constant 2 there. It's really going to be 1/2. So you can pull that out. 1/2 integral 1 over u du. So as you guys can see, what I did here, we have to recognize what integral that is. That's the integral of 1 over u du. So go back to the formula sheet here. And when I created this for you guys, this is where it came from. If you guys remember, we derived this in class here. That the integral of 1 over u du is natural log absolute value u plus c. And that's the u subversion of the formula 1 over x dx being natural log absolute value of x plus c. So it's natural log absolute value u plus c. So that constant now, 1/2 natural log absolute value. Now you say, Mr. Judge, that's just a constant. It is 1/2 natural log absolute value. Now remember, u is x squared plus 4. And which you can see now, that absolute value becomes a parentheses. Simply because, if you take the absolute value of x squared plus 4, or I should say x squared plus 4 is always positive. Right? You get an x value. If it's negative, you square it, it's now positive. If it's a positive value, you square it, it's positive. And if it's 0, it's 0 squared, which is 0, but you're adding 4. So the point is you get a parentheses now, and this is my first integral. This is what we call I1 in orange. Okay, this is just I1. We need I2, or 4 times I2. So if I said to you, here's 4 times I2, and that was green, I guess. We'll color it all green because that's a plus. Okay. Well, anyway, let's just do this here. Integral of 1 over x squared plus 4. So I'll just say in green, I2. I for integral. 1 over x squared plus 4 dx. Now pay attention to this 4. That's going to be written as 2 squared. All right, and you say, well, why would I do that? Okay, this is the a value. A value is 2. That number. So I have to look for the formula for 1 over x squared plus a squared. So you want to know your formulas, ladies and gentlemen. Know your formulas like you know your name. Don't go back and looking at this, sheet here. Here's what I'm saying. There it is. It's 1 over a inverse tangent x over a. Now we said a here was 2, right? So, all right, a here was 2. So here's my point. 1 over a, that's 1/2. Inverse tangent x over a, well, that's x over 2 plus c. And ladies and gentlemen, that's your green integral. Just by knowing the formula here of 1 over x squared plus a squared. All right, that's the deal there. So you say, what is this all together now? Well, all together, remember, this is going to be I1 plus I2. And we already found I1. That was 1/2 natural log. It's right here. X squared plus 4 plus c. And I just found, don't forget the 4. 1/2 inverse tangent x over 2 plus c. And you might say, where's my c? You can call that c1, c2. Okay. And final answer now. Just change the color. 1/2 natural log x squared plus 4 Now 4 times 1/2 will give you 2. This is, I'm saying, your arithmetic right in here. 4 times 1/2 is 2. Inverse tangent, x over 2. Now, you can say C3 because you added constants plus C1 and C2. The answer is another constant called C3 if you wanted to be OCD, or you could just say plus a constant. All right, you guys okay with that one? And yes, ladies and gentlemen, this is how you go about answering these kind of questions here. You know, this is the last one, I believe, number 21. And so take a look at that worksheet I gave you guys here. Okay, you have even questions that are all done very, 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 very similarly, I would say. And, but here you go. This is integration here of inverse trigonometric functions. I hope you guys enjoyed the demonstration.